folks. Welcome out there. This is Mathline Summer School, and the living is easy. I'm Ernie Roberts. I'm your host for TNLearn Mathline Summer School version. We're glad you've tuned in this afternoon. We are excited to be here. We hope that you are too. And you know what? We've got some good stuff, maybe a little bit lower key, lighter fare for summertime. So why don't we check it out? Let's see what we've got going on today, guys. What we got happening here? We're going to dance. The two-step equations, that is. All right, so we're going to look at some equations that have two steps, and I'm going to be honest with you, they may have more than two steps, but if you can dance the two-step, you will get to the final steps of these equations, all right? Just about guaranteed, all right? But one thing that you need to know, sometimes you need to know how those times tables, how to divide, how to subtract, how to add, because that's what equations are. They are just ways that we translate situations into numbers, all right? So let's take a look at what's going to happen in our first dancing step here, all right? We're going to solve and check. That's going to be the idea today. We're going to solve equations, and we're going to check. Key thing, I want you to start getting in the habit of that, because especially when they're nice numbers. Now, if they're rough numbers, sometimes you go like, I don't like to do that, and you take a chance. I know, I do the same thing. But if you put in that number back in there and make sure both sides are equal, that's the whole idea, my friends. We're trying to find a value of x that will make the left side and the right side balanced. They'd be even. They would be even, all right? So let's take a look at our first problem here. We've got 12 times x, or 12x as we like to call it, and we're going to add 30, and we get 54. Now, that would read 12 times some number added to 30 is going to give us a result of 54, all right? And these kind of things are what we call linear equations, but we're just going to call them two steps today also, all right? So there we go. We got the problem written down. Now the thing is, the idea is let's get x by itself. That's what the two steps are about, all right? First thing we notice, we've got a 30 that we don't like. We've got a 12 we don't like, all right? We can do better without them, all right? So let's do the good thing here. Let us subtract. And you say, why are you going to subtract? Because I see a plus 30. How do I get rid of a positive 30 or a plus 30? I use the opposite, or the inverse operation. And that means, very simply, when I see an adding of 30, I'm going to subtract to get rid of it. And if I do it to the left side, I'm going to do it to the right side. And folks, that's what we call a good old friendly property called the subtraction property of equality, all right? So those things just never leave us, it seems like, and they never seem to leave my mouth on Mathline. They're always there, coming back after you over and over and over again. So again, properties, very important also. So let's do some good old subtraction. Like I said, those are some of the operations we got to remember how to do. We're going to subtract 30 from 54. That's going to give us 24 over there. And we're going to say goodbye to these 30s because they cancel out. That's the whole point of subtracting that. So I'm left with 12 times some number to give me 24. In other words, 12 times x, or 12x, equals 24. To solve from here, folks, this is a connection by multiplication to unhook or disconnect. We'll best say unconnect. That's not such a word, is there? Y'all can tell me about that. But to disconnect that 12 from the x, we've got to do the opposite. And again, it's connected by multiplication, so we're going to take and divide both sides by that 12. Clean it up, and you know what we got? We got a final answer. We got x equaling, it goes in there 2 times. So we have solved. We hope that we have the right answer. We're going to check, all right? And so what we're going to check, we're going to go back to the original equation, which is 12x plus our 30 equaling to 54. Now, some of you are capable of doing this thing in your head, all right? But do something. Do it either mentally or write it down just like we're going to do right here and show what's going on. We've got 12, and we're going to put in a 2. We're going to add 30, and we're going to see, do we come up with the same value on both sides? Well, I know that's 24. Add 30. Dear friends, we have 54. And that checks. So that means x equals 2 is a good answer. It's a good answer. It solves, it makes this thing balance. That's what we're wanting. That's what we're wanting. So today, that's going to be our story. We're going to be looking at various situations where we basically are going to isolate an x, a y, a p, some sort of variable, and then we're going to go back and make sure it works. All right? We're going to make sure it works because on Mathline, it's very important to check your solution. Let's take our next problem here. All right? It says solve and check. Once again, the instructions are not going to change. All right? Today, we're simply going to be solving for a variable and checking away. So let's see what happens. I'm going to rewrite it while you all have a chance to put that down at your home viewing here also. And it's 5 times the number y plus 14 is going to give us 29. Gives us 29. Again, we want to find the value of y that's going to make both of these sides equal to each other. In other words, what's going to make this expression come out to be 29? So you may be already starting to think, I can come through some ideas in my head, I think, and do this. Well, you know, it could be. It could be very, very true. But let's work through our method. All right, let's work through our method. We've got a 14 that needs to move. It is in there by addition. We also have a -5 in the front of this y value. That's a funky looking y, isn't it? Well, there it is. It's still kind of funky looking. We could work the whole show trying to get that to look right. But it's a y. Let's get rid of the 14 here. Let us subtract, and again use our subtraction property of equality to the left, which means we're going to do it to the right. All right? So we subtract 14 off both sides. Kicking along here, folks, we got it. 29 minus 14, that is going to give us, what's it going to give us? 15, right? 15, there we are. And here I have this -5y. I'm going to make that a better y. All right, that's better. Now, what's happening here? We're going to divide -5 into 15, all right? So we're going to use, by the way, it's called the division property of equality, for those who are wondering. What says we can do that? That's simply, if you divide the left by -5, you're going to divide it to the right, okay? And sometimes we just simply divide it right in there, especially if we don't have any fractions or strange things that are going to happen. But what's going to happen? It looks like, speaking of which, the 5s are going to cancel each other beautifully. Then we're going to divide -5 into a positive 15. Remember, folks, negative into a positive will give us a negative, and it looks like we have a -3. Quick check. Let's take -5, let's put in the -3 for the y, all right, since we know we're coming back to the very beginning. Go back to the very beginning, that's the only way you can check. Plus 14 equals 29. Some people ask, Ernie, why do you go back to the very beginning? Because you might have made a little error somewhere along the way here, all right? That's the whole idea, is to come back and make sure the original statement is balanced, because that error may have happened at the very end, it may have happened at the very beginning. And you may not have made any errors at all, and that's what we hope didn't happen here, all right? We've got 15, we've got 14. That definitely gives us 29 to both sides. So it checks, and folks, that's a good answer. It's a good answer. All right, so as we work with our problems here on Mathline, we solve them and we check them. Even though it may seem very easy, it's good sense. Because when the problems start getting a little bit tougher, then it's a good idea to be able to go back and put in your solutions and make them work. Make them work. That's the whole idea. And not force them to work. They've got to work naturally, the way the problem was given to you. So speaking of which, let's take a look at our third problem here we've got going. It says 27, and from that we're subtracting 6 times some number c, and we're going to have a result of 12. All right, let you all copy that one down. Looks like I'm writing a little downhill. We'll straighten that up as we move along. First of all, notice the order here. So many times we're used to seeing the 6x or 6y, or in this case the -6c, at the front. This one moved to the middle. It's still the same process. We need to remove this 27. We also are going to have to eventually remove the -6. Whatever, my friends, please, please listen very carefully to what I'm about to say. Do not say 27 minus 6 and get 21. That is not going to work. It's not what it means. It means simply 27, then we've got to worry about this, and the result has to come out to be 12. So let's see what happens. First of all, that 27, folks, it's positive. So we're going to do a minus 27 to both sides here. Once again, we subtract from the left, we must subtract from the right. Subtraction property of equality. Those are gone. And another thing that my students a lot of times forget to do on a problem like this, they forget to bring down the subtract as a negative, because it's still there. It's important. If you don't, you made this whole thing become an addition, and it's not. It is a subtraction still, all right? Or in this case, it's going to be divided by a negative, all right? So be very careful on that. On the other side over here, we have a, goodness, it looks like a -15. Now notice the signs are different. And in this case, we're trying to subtract 27 from 12, so guess what? It means our value is negative over there, and it is basically under by 15, all right, when we subtract that out. So -15, let's do the division. Let's do the division. And this is one of those we're going to divide both sides by the -6. Again, we said 6 times c, so in order to get the 6 by, let me start over again. In order to get the -6 out of there, tongue twister there, guys. And in order to do that, we have to divide by the negative also. We're going to take care of that We lose everything. We've got a c by itself. And we have a negative divided by a negative, which is going to give us a positive. And folks, that's going to actually be 2.5. And some of us like to have it 2 5/10, or really affectionately call it 2.5. Let's see what happens when we plug these numbers in. All right, going back to the original equation, it says 27 subtracting 6 times that 2.5, and we hope to get 12. All right, that's our goal, is to come up with 12. Now, here's 27. That isn't going anywhere. Remember, my dear Aunt Sally says we multiply first. That's why we want to make sure that we bring this down, okay? Because when we check, it would not have given us the right answer. Because remember, we got to multiply, then we do the addition or subtraction, whatever's left for us to look at. And in this case, it's going to be 15. And you know what? Does it give us 12? 27 minus 15? Yes, it does. So 12 equals 12. We check. We check. Life, as we say, is good. All right? And there you go. That's why we have to check, because some of you may have not done that right. You know, you might have done that, I was going to worry about that 27 minus 6, you got 21, and you had a mess, all right? And it would not have checked, But you would have caught it that way. You would have caught it. So let's see what we've got going on in the next one here. We're going to let you write this one down. This time it says, and I'm going to write it a little more explicit here. It looks like it's an x divided by 5. That's what exactly it means, all right? It's a fraction, and that's what fractions are. They're all about division, So we got x over 5, x divided by 5, x fifths. That sounds a little weird. So we'll just say here we got x divided by 5 minus the 12 equals to a negative 17. This time we have a minus 12. That's the first time we popped one of those up there today. But what we've got to do in order to get rid of a minus 12, guess what? We do the opposite operation, which means we're going to add 12. See, we want these to cancel. A negative 12 and a positive 12 give us 0. That's the idea. However, on the other side, we've got to do the same thing. I bet you know this is called the addition property of equality. Yes, yes, yes. All right. So let's see. We're going with this. We have x over 5 still, or x divided by 5. On the right-hand side, I have a negative 5. And you say, Ernie, how do we do this? Well, we have a division situation here. How do we disconnect division? We are going to need to multiply. And I've got a 5 down here in the bottom, all right? So we're going to multiply both sides by 5. We'll call that the multiplication property of equality. And see what happens when you put a 1 into those 5's cancel. That's the beauty of it. That's like a 5 over 1 times x over 5, the cancellation of multiplying fractions. Okay, that's the beauty of this. We have x left over. On this side, we've just got negative 5 times a 5, which is going to give us negative 25. Let's see how that works. Go back to our formula. Formula says we're going to put in negative 25, put it over 5. We're going to subtract 12. And we're hopefully going to come up with a negative 17. Now, if you look at that, you're getting a lot of negatives going on here. So that's negative 5 minus 12, which will equal your negative 17. All right. And, oh, by the way, does that work? Surely it does. Checks? Checks both ways. All right. And when you're looking at that, once again, it's just going back. You can do that mentally. You can also do it physically, okay? Write it down on your paper and so forth, all right? Those are our stories. Those are our stories today, all right? So that's the general basics. When you multiply, you subtract, you add, you divide. All those options are all there. And let's see what happens if we stretch things out a little bit. We've got a thing called, let's see, go ahead and write that down at home, folks. So we've got 2x minus 5x plus this 23 equaling 20. By the way, those other problems were 2 steps. Actually, we could probably say 3 steps since we have to check. But if you solve, that's 1 step, then check. It's 2 steps, all right? And then you also do some steps within. I know. But now let's see. We've got 2x minus 5x. Ooh, those look like they could go together. They actually do because they're like terms. So a 2 minus 5, that puts us into a negative situation. So we're going to have a minus 3x right there, okay? Now the 23, it's its own person, all right? It hangs out there by itself, as does the 20. This 3x cannot mix with them, all right? The only way we're going to be able to mix it is when we do some division, but we're not ready to do that yet. I don't like 23. It's kind of a nasty looking number right there because 3 doesn't divide into it very well. However, it doesn't divide into 20 either, some of you are telling me. Yeah, But what we are going to do, we're going to just work this like a problem we've had before. We're going to subtract 23 both sides. And how clean this is going to look. Oh, it's going to look good. We have a negative 3x on the left. That's all that's left over. On the right, we're saying 20 minus 23. Folks, that takes us into a negative territory also. So it's going to be a negative 3. It's going to be a negative 3 because we're going to subtract that 20 from 23 and give it the sign. That negative right there goes with it. Now, dividing out. Divide that negative 3 to both sides. And divide it into a negative 3, it's going to give us, some of you say, oh, that just cancels out. That's 0. No, it isn't. No, it isn't. No, it isn't. Cancels out to give us 1. And that's exactly what it's going to give us there. And it's going to be a positive, by the way. It's going to be a positive 1 because we divide two negatives into each other, and that is what happens. We get a positive value. Now, let's go back and quick check. All right, let's see here. I've got 2x minus 5x. And remember, we go back to the original, because some of you might have put the wrong thing right there off the bat, all right? Let's put a 1 in for each of these, all right? So it's 2 times 1 minus 5 times 1 plus our 23, and we should get 20. That's what we're hoping for. That's what we're hoping for. So this is going to be 2 minus 5, and then we're going to add 23. The question is, do we come up with 20? Whew, I hope so. 2 minus 5 is going to give me that negative 3. Add that to 23. We are at 20. It checks. And again, folks, when you get an integral value, whether it's positive or negative, it is really easy to substitute those back in the original equation and see, does it work out? Does it get you where you want to go? It is so much better to do that than to miss the problem, okay? So let's see our next one here. Ooh, switched it up a little bit. And I threw a fraction in. Oh, everybody's going like, ugh. I thought this was summer school. We weren't going to have to play with fractions. Well, you know, it's still part of the game. Still part of the game. Let's see what we got. Let's rewrite the problem out there at home. And you got 40, and we got 4/5 of y. And we're going to subtract 20. All right. First of all, some of you are also noticing, Ernie, you put the variable on the right side. Is that legal? Yeah, it's okay. It happens. We're still going to come up with 40 out of this. That's our goal. That's our goal. Let's come up with the expression of 40 there. So let's see how this is going to work. First things first, it's the same story. You've got a minus 20 that needs to move. You've got a 4/5 that's got to go somewhere. So let's see how we're going to deal with these. We're going to add 20. That's the first thing we're going to do. Isn't that nice? We're going to add 20. And we're going to add 20 here. That's going to give us a value of 60. And of course, these guys, the whole point of using them was to make them go away. They're gone. So now we have 60 is equal to 4/5 times y. Okay, or 4/5 of y, we like to say that, all right? Now, how do we get rid of this 4/5? We can do a two-step process. Another two-step. Well, we're dancing a lot, aren't we, today? We can multiply the 5 out of there and then divide by 4. Or we could kill it in one stone. Ooh, you know, that sounded kind of a little rough. Well, let's see. Let's go for that. Let's see if we can do it in one move, all right? Let's take the reciprocal. Reciprocal, that means we're going to invert. We're going to change the numerator and denominator position. We're going to move the denominator to the top, numerator to the bottom. But we're going to multiply. And I'm going to put it on the outside there just to keep it in form here. And the big thing you got to remember, my friends, is you multiply by that same value over here. You put that, and go ahead and drop a 1 under that 60. Go ahead and make it a fraction. This will make it a lot easier to figure out where things are going. Let's see, we can can the 5s, we can can the 4s. That's why we use 5 over 4. Now I have sometimes my students try to put a 4 over 5 again, and then do it over here, and they said, didn't I get it right? Although they didn't really put it over there because then they would have seen, ooh, it didn't cancel. That's the whole idea. We want these to cancel out and go to 1s. Go to 1s all the way around, and that's what they do. Now over here, we can divide 4 into 60. It's one of those unknown factors. Well, actually, it does divide into 60 very nicely. It's 15 times, but sometimes we forget that exists, okay? And it looks like we got 5 times 15 going across the top. That is worth 75. And you know what? That's y by itself. There's our answer. There's our solution. You say, Ernie, are you going to check this one? Of course we're going to check this one. Let's put it in there. I don't think we need to. This 4/5 times 75. Ooh, and then we minus 20, and we're going to get 40. That's the goal, all right? We can move that. That's, by the way, called symmetric, when I can shift left side and right side completely in their order. But that's what I did. I just simply moved it around here so we can see what's going on. We are still trying to get a 40 on the end, okay? We have a minus 20. Obviously, this is the big deal. You're going to divide 5 into 75. Guess what? It goes 15 times also. 15 seems to be a magic number here. Take 4 times 15, we get 60. And you know what? 60 minus 20? It does give you back to 40. Checks out. Checks out. So again, it's not that irritating to solve and check, especially if you're going to get the right answers. That's what you want to do. It's what you want to do. All right? Now, let's stretch this a little bit. Do a stretch problem here. It says solve and check. I've got a parenthesis brought in here. You say, what do we do with the parenthesis? What do we do with the parenthesis? We are going to distribute. All right? And so while you're at home, let's rewrite this. So we got it, all right? But I just want everybody to know that's what we're going to do. Notice I didn't take it beyond that parenthesis. We're not going to distribute into the 6p or the 40. We're just going as far as the parenthesis lets us. So let's see, we got it equaling to 40, all right? All our signs are good. Let's play, all right? Now, 4 times p, it's just simply 4p. And 4 times 5, we're going to go right back here with these arrows so you know where I'm going, is going to give me 20. Gives me 20, all right? Plus 20, everything's good. Minus the 6p value equals to 40 on the right-hand side. Now, parentheses are gone, and that's good. That's good, because now all we want to do is figure out how do we get p by itself. Well, one thing that will help is to join them, because they are like terms. So let's put 4p and minus 6p together. That's going to give us a negative 2 times p, adding 20, equal to 40. I like all these zeros because we can do a lot of arithmetic in our head. Now, you know, these problems can look really nasty. They can be nasty numbers and such. But when you're learning it or when you're reviewing it, just to get the steps and make sure you've got the procedure down, numbers don't have to be exactly excruciating. In the real world, they'll be tough numbers to crunch a lot of times. So enjoy it today. It's summer school, right? That's why we're doing it easy. Now, let's take a look at this 20. It needs to move over. We're going to subtract 20 both sides. And you've got a negative 2p. Over here on this side, you've got a 20. And I like that because those divide so nicely. According to this, it looks like p is going to give us negative 10. Negative 10, all right? Now, let's do the check. Let's do the check. All right, let's see, we've got p, and I'm going to go ahead and put the value we put in there, this negative 10 plus our 5 minus 6 times our negative 10, and we're going to get 40. That's a lot of stuff going on there, folks. Work the parentheses. Remember, a good old please excuse my dear Aunt Sally says go parentheses first. So we're going to take 4 times negative 5, and we're going to take this negative 6. We're going to subtract times whatever that gives us with that negative 10, equaling to 40. So very carefully here. This part gives us negative 20. This is like saying plus a negative 6 times a negative 10, all that good stuff. This is going to give us a positive 60 to equal to 40. And look what we have. We have 40, 40, it does equal. And on a problem like this, folks, there's a lot of places you can make mistakes. You can misdistribute. Many times my students come along and say 4p plus 5 and forget about getting the 20. That's one of the places where you just tell yourself, focus, focus. Sometimes we mess up because we don't notice that there's a minus waiting for us there, and that's important. That's important. When you put like terms together, you've got to get that negative 2p out of there, all right? Put it together. When the 20 is there, make sure you don't just add 20 and 40 together, all right? That causes problems too. So those are little ways that errors can happen, but with these nice round numbers, it's easy to spot it. It's easy to spot when things don't go according to plan, as sometimes they do. And folks, I tell you what, we are come to the close of another great day of Mathline here in summer school. We do remind you we're still around on YouTube, all right? And we're going to be putting up some stuff there. We still got our problems of the day from past year here. www.youtube.com/TNLearn. And of course, that great Mathline at TNLearn.org for sending email, and there comes our Facebook, TNLearn also. Please send us your comments. Like us there. We love it when you like us. Isn't that cool? We love it when you like us. And we do appreciate you tuning in today and throughout the summer. It's going to be summer school for just a few more. Once August the 8th comes, we are back live 4 days a week and having fun on Fridays also. But you know what? Again, thank you for tuning in today. It's great to have you with us. Hopefully this was a good little reprieve. You've got to see some equations. You got a little challenge at the end. You had a little fun at the beginning, and hopefully you had fun throughout, all right? Because that is what we're about here on Mathline, especially during the summer school times. So get ready for your school year coming up. That's why we're doing what we're doing, these reviewing basics. Yes, they're basics, but you know they're fundamental. We don't want to make careless mistakes. Right. Hey, thank you for tuning in today. That is definitely not a mistake. We got you. See you tomorrow.